Alright, so in this video I'm going to go over the review for the first 3 chapters, and then additionally chapter 10 is on this assignment. So the first chapter was about points, lines, planes, distance formula, midpoint formula, and then just some vocab for how we describe angles. Also on there were polygons, like concave, convex polygons, the names for the sides of the polygon. So for example, like an octagon, knowing that that has 8 sides. We went up to, I think, 12 sides, but I'd really only focus on the first 10. So first 10-sided polygons. With 3-dimensional solids, their names. We did do surface area, but we're not going to have to worry about that for the final. The only thing that really will be important for 3D figures is being able to name them, and then also their volumes. So let's go ahead and go through some of this. It says name 3 points that are coplanar and can be used to name a plane. So really important here, 3 points that are coplanar, they all have to lie on the same plane. And because it says that they have to be used to name the plane, they can't be collinear. So they can't be 3 points on the plane that are in a straight line. So if we're naming a plane using 3 points, they cannot be collinear. So let's say we'll name plane P. And we can use any 3 points that are not collinear, so C, B, D would be a good way to label that one. Obviously, we could have answered for plane R and used 3 points that are not in a straight line there. What is the intersection of AD and plane R? Plane R is the one that's vertical here, and AD, so the intersection of that plane and that line is a line. So it's either you can use AB to describe it, BA, or you can use anything with D, so DB, any of those things would work. What is the intersection of plane P and plane R? Well, the intersection of 2 planes is always line, and it is the same answer as number 2. It is this line right here in the center, so you can use any 2 letters from that line to name it. Number 4, distance formula. The distance formula is the square root of the changes in x. So we had x2 minus x1 squared, and then plus the changes in the y. So y2 minus y1 squared. All right, so the way I do this is I just first change in x, I just say how far apart is 4 and 2. That's 2 apart, so I use 2 for this part of my formula, so that'd be 2 squared. And then I add on how far apart are my y's. I don't worry about whether they're positive or negative, because the formula will square that number and will automatically make it positive no matter what. So all I gotta do is make sure I know how far apart these numbers are, and then I'm good. So -7 and -1 are only 6 apart, so I need to square 6. So my answer for distance is going to be the square root of 4 plus 36, which is the square root of 40. So keep in mind the square root of 40 could also be expressed, simplified. So this could be 2 times the square root of 10. And this is multiple choice final exam, so if you got the square root of 40 as your answer and you didn't see it, you can just plug the other options into your calculator until you get the one that is exactly the same. Midpoint formula, midpoint is a point, so the answer to this is a point, and it is the middle of each x and the middle of each y. So the middle of the x's goes right here. The x's are 2 and 4, so the number that is in the middle of 2 and 4 is the number 3. And then for the y's, it's the middle of the y's. So what number is perfectly in the middle of -6 and -1? Well, that would be -4. And the way to calculate that, if you can't come up with it on the top of your head, is to average them. So you can add -7 and -1 together, divided by 2, you should get -4. So that is midpoint. The midpoint formula is x2 plus x1 halved. So it is quite literally, the formula is to average them, which is the same thing as finding the middle. So that's what the midpoint formula is. Name the solids in their volume. This is a prism because it does not come to a point like this figure over here comes to a point at the top. This one does not do that. This one has flat sides. They're all rectangles. This is called a rectangular prism. And the volume of a rectangular prism is just length times width times height. So the volume of this is multiplying these 3 numbers together. So 8 times 5 is 40, times 6 should be 240 cubic yards. And again, this is a rectangular prism. This one is not like the first one. It's not a prism because it comes to a point at the top. So this is called a pyramid. And the type of pyramid this is based on what its base is. And what is the base? The base is the face that is underneath the top point. So if I go to the top point, I look straight down. The base is this shape here on the bottom. So it's the flat shape, and then it does come all up to a point. That flat shape at the bottom is a triangle. So this is called a triangular prism. Maybe it might help to show you what a rectangular prism might look like. So a rectangular prism would have a rectangle at the bottom, like that. And then all of those corners of the rectangle would all come up to this point. So it would look like, excuse my terrible drawing, but this is what a rectangular prism would look like. You can see they look very similar because they're both, pyramid. This is what a rectangular pyramid would look like. You can see they're very similar. But the difference is the bottom shape on this one is a triangle, whereas the bottom shape on this one is a rectangle. So how do you find the volume of a triangular prism? I believe, I should double check to make sure I'm saying this right, it is the area of the base times the height times a third. So let's make sure that that's right. Volume of a pyramid. I just don't want to misspeak, but I'm pretty certain that's what the formula was. Yeah, so length times width times height times times a third. That's for rectangular, so I just want triangular would just be the area of the base times the height times a third. Yeah, so that's what I said. Just wanted to make sure I wasn't doing that wrong. So the area of the base, you can see the base here has a right angle, which is really nice because for a triangle, the area of a triangle is 1/2 times the base times the height. So we're just calculating the area of the base here. It's 3 base and 3 height. So it's 3 times 3 times 1/2. And that's 4.5. So 4.5 is the area of the triangle on the bottom. We have to multiply that by the height. The height here is labeled as 4, so multiply that by the height. And then our formula says to multiply it by a third here. So 1/3 times the area of the base times the height. So the area of our base was 4.5. Our height was 4. And we just have to multiply that by a third. So whatever you get when you do that is going to be your answer. So what's that? 18 over 3. So that is 6 1/3. It should be, wait, what am I doing? Is it exactly 6? Yeah, this is exactly 6. So there's your answer for that one. Find the area of this trapezoid. To find the area of the trapezoids, there is a formula for it, but what we'll do is we will just draw a line straight here, and we will find the area of these 3 figures and then add them together. So the one in the middle is a rectangle. That's pretty simple. That is length times width. The length at the top is 5, the width is 3, so this has an area of 15 here in the center. This triangle here on the left, the area of a triangle is 1/2 base times height. The base is 2, the height is 3, so that is 6 times 1/2 would be 3. So that has an area of 3. And this one doesn't have dimensions, but we can figure this out pretty quickly. What you have is a height of 3, so this is still a 3. And this length is not so easy to calculate. And it's hard to tell what this 9 is describing, so on your final exam it'll be more clear what it's describing. I'm going to go with the 9 is describing from here to here. It doesn't say that explicitly, but that's what we're going to roll with for this question. So the top part here is 5, the bottom part here is 9, so this piece is the difference, so this piece is only 4. And then we have a triangle with a base of 4, a height of 3, so 4 times 3 is 12, and the formula says I should half that. So that triangle there is 6. So we have 3 plus 15 plus 6. That's going to come out to 24 square centimeters. There is the first chapter. Second chapter, P's and Q's, converses, inverses, contrapositives, etc. So the converse is where you switch the order. So the converse of P then Q would be just put Q first, put P second. Inverse is just putting a not in front of each. And the contrapositive is a combination of both the converse and the inverse together. So we would switch the order and make both of them a not. And this little squiggly symbol means negation, it means not. So here we have 3 statements, P, Q, and R. P is true because 10 minus 8 is 2. Q, a rhombus's diagonals bisect each other. That is true. And R, a kite is a parallelogram. That is false because the opposite sides in a kite are not parallel to each other. So as they stand, P and Q are true, R is actually false. So our first statement is P, this is and, so and means they both would have to be true to call this true. We have P and Q, both are true statements, so the final conditional statement is true. We have P and this is or, so that means only one of these has to be true so that we can call it true. We start with P. P is already true, so it does not matter what this is because P was true. So we can just automatically call that true. Okay, this one, some really fancy stuff. We have not P and not Q. So remember, and means they have to work for both. Okay, so not P, if we go back to P, P was true. So not P, this itself right here in the beginning is a false statement. So false, and automatically I can stop because for this to work, since it's an and, both of these statements would have to be true. This one is already false, so this, all these parentheses gives us a false statement, okay? But we have an or here, so it says false or whatever R is, and or just means it has to work for one or the other. So if I go back up here to R, I'll find that R is also false. So this says false or false, so this one's actually gonna be a false statement. This proof's pretty simple. Make sure you start with the given information, so copy down the given information. We're going to use two things in this proof. We're going to use vertical angles are congruent, so 2 and 3 are going to be equal by vertical angles are congruent, or just vertical angles. And then you're going to use something called the transitive property. So you're going to say 1 is equal to 2 to start because DB bisects that angle, and that's by definition of bisector. So 1 is equal to 2 by definition of bisector. 2 is equal to 3 by definition of vertical. Therefore, 1 is equal to 3 by the transitive property. So that's kind of a run through real quick of what that proof looks like. For this one, we'll tape if angles are 1 and 4. 1 and 4 are right beside each other. So they're called consecutive angles. So consecutive, let's just type that. Consecutive angles. They're also, because they form a linear pair, you could say that they're a linear pair. And then because they're a linear pair, they are supplementary. Did I put an extra E in there? Probably. No, that looks fine. So that's basically the three different things that you could call angles 1 and angle 4. Angle 1 and angle 2 are vertical angles, and because they're vertical angles, they're congruent to each other. So there's that. I'm going to end this video now. I'm going to make a separate video for chapters 3 and chapter 10 stuff. So that's the circles and the transversal chapter, just so this video doesn't get too lengthy.